Okay, so in this last example, I'm going to involve something that has a trig function. The steps are exactly the same as before. What makes this process difficult is how complex the function you are given is and how hard is it to find the derivative and of course solve for CP. So that's really all I'm changing here is I'm giving you an example with some trig. So again, we want to first consider our interval. We're dealing with trig, so you obviously appear the radian and the pi appear. I'll call this f of x so you know exactly where I'm getting those y values. And I'm going to start with the first one, which is 0. And then the last one that I can use is 2 pi. That's where we end. So if I plug in 0 here, I'm going to go ahead and show this process since we're dealing with trig. I get 0 times the sine of 0. 0 minus 2 times sine of 0. From your unit circle, you will know that sine of 0 is 0. And so therefore, when you plug in 0, you also get 0. 0 minus 0 is 0. Let's now go to 2 pi. And I get 2 pi minus 2 sine of 2 pi. From the unit circle, we also know that sine of 2 pi, which is the same place as 0, goes to 0. And so we're left with 2 pi. So I'm going to leave it that way for now. 2 pi to 2 pi. Sorry about that. Let's put it in the right spot. Something I want to say about this is that just to imagine what 2 pi is, 3.14-ish times 2, so it's going to be above 6. All right, let's go ahead and move on with our actual CP process. So that's where us finding y value. So let's take the derivative of x. Still nothing major, just 1 minus 2 cosine of x. And I'm going to go ahead and think, is there anywhere where this could be undefined? 1, not a problem. Cosine is a continuous function, so we're okay. And so now we'll just go ahead and set it equal to 0. And we'll move the 1 over, so we're going to try to isolate this cosine. And then we'll divide by negative 2. So cosine of x must equal positive 1/2. So what that means is we got to look for angles in the unit circle to solve for x. Kind of a review of solving trig functions or trig equations. Is that you want to get the right color here. You want to solve for x represents an angle. So basically this is asking you at what angle does cosine equal 1/2. And so if you kind of look at your unit circle, you remember our points are 1, 0, and cosine is related to x, but it's square root of 3 over 2, 1/2. And that happens at pi 4s. Then, pi 6. And then square root of 2 over 2. That one happens at pi 4s. And then at pi 3rds, you get 1/2, square root of 3 over 2. So that's the one we're looking for. We have the x to be 1/2. So it happens, the first one happens at pi 3rds. So I'll put x equals pi 3rds. So again, what angle in the cosine function would give me 1/2? Now there's the other angle here that will give you a 1/2, but the problem with that is that it will now be negative, and we really don't need it to be negative. There will be another angle here that will give you the same answer, but again, we don't want it to be negative. We need it to equal positive 1/2. And so we have to go back to the right side of the y-axis, quadrant number 4 here, to see that here there's an angle. It's 5 pi 3rds. 5 pi 3rds is the other place where we're going to get positive 1/2, negative square root of 3 over 2. Again, we're looking at the x coordinate here. So we actually have two answers. We have x equals pi 3rds and x equals 5 pi 3rds. Okay, and I can't keep going because if I do, now I'm exceeding my interval. So you can see here that the next iteration of this is going to give me something above 2 pi, and I can't have that. I'm only interested in things between. So I have pi thirds here and 5 pi thirds here. So what I need to do now is to figure out my y values for these. Okay, and now what that means is I'm going to take this pi thirds and I'm going to plug it into f of x. And so I will get, I can show you here, that might look like, let me scroll down a little. And it's not going to be something that we're going to be able to do in our head. We might have to use a calculator, but if I want to find f of pi thirds, I'm going to plug in pi thirds. So right there is the first issue. Pi thirds over 3 goes in for x. I don't know what that is off the top of my head. 2 times the sine of pi thirds. You should know sine of pi thirds is square root of 3 over 2. There it is on the unit circle. But even if I do that, the 2's cancel. I'm not really sure what this is, so I'm going to have to put it in the calculator. And if I do, I get it. And remember, I have to know the y value because I'm trying to figure out if it's higher or lower than, so we want to know if it's higher or lower than 0 or 2 pi. Okay, so we're going to take our 2 CPs that we found, pi thirds and 5 pi thirds, and we're going to plug them into the original. I've kind of showed my work already for the first one, but it's not something I'm going to be able to do in my head. So I plug in my pi thirds, sine of 2 sine pi thirds, which is square root of 3 over 2. But even then, I'm not going to be able to do this in my head. So if we just go over the calculator and let it do the work, I think that will be a little bit more safe with this. So we'll put a pi thirds here. That's my CPs. And I'll put 5 pi thirds here. And then I'll just go to the calculator, and what I get is negative 0.6849. And then for 5 pi thirds, I get 6.96. I think that's a 6.8. Okay, if you do 2 pi in the calculator, it's going to be probably a close competition there with the 6.9668. Let me see. 2 pi. So the 2 pi is actually going to be a little lower, 6.2831. So we have here the winner. The absolute max is going to be happening at 5 pi thirds. Probably should have done that in red. That's our absolute max. And then our absolute min, of course, is going to be here at negative 0.6849. That's our absolute min. And so there you have it. And remember, those refer to the y values, not the x's. Now let's take a look at it graphically just to show you exactly what I mean. See, I have it on Desmos. So I have here the graph. You can see I've cut it off from 0 to 2 pi. You will notice, let me get my writing tool. You will notice that our CPs appear here. It's not quite at 1, a little bit past, so this is gonna be your pi thirds, and this one over here is gonna be your 5 pi thirds, and that of course is the highest point in the graph. We do have our endpoints here, but those are just relative. This one is a relative min, it's lower than the stuff before it, and this one is gonna be a relative max, it's higher than the stuff right after. So there it is. There's a visual of the problem for you to better process what we just did. Awesome. Hope these videos helped. And we'll see you soon.